Assalamu alaikum. I am Sunil Kumar. Welcome to you all for today's physics Telikilaas. Today our topic is fusion, fission and some revision questions. Objectives. By the end of this lesson you have to define nuclear fission, nuclear fusion and you have to do some questions from this topic. First we can check nuclear fission. In nuclear fission, large nucleus split into smaller nuclei and with that it releases lot of energy. Now you can see when a neutron hits a large nucleus, it split into smaller nuclei and release lot of energy, and this process is called nuclear fission. Now nuclear fission is an exothermic reaction, and detail about exothermic reaction maybe you study in chemistry topic. So look, we know exothermic means energy releasing reactions. Okay, some of the masses of the resulting nuclei is less than the original mass. That means large nucleus break into smaller ones, and when we add the mass of these two will not be equal to the large one. So what happens to that mass? Now look, the missing mass is converted to this energy. I already told lot of energy is releasing, the missing mass is converted to this energy. And nuclear fission process is using in nuclear reactors. Nuclear reactors, we know it is used to produce electrical energy, electricity. Okay, so now we can check in nuclear reactors how this process is going on. Energy is releasing, and in nuclear fission process lot of energy is releasing. That energy boils this water, that energy goes to the water and water boils, steam produced, steam rotates the turbine connected to the generator produce electricity. And in nuclear reactor first nuclear fission process is going on. Nuclear fission process release lot of energy. That energy goes to the boiler, and when the heat energy reaches to the boiler, the water boils and produce lot of steam, and steam rotates the turbine is connected to the generator, and generator produce electricity. This process is going on in the nuclear reactors. Okay. Next one is nuclear fusion. Nuclear fission, we know large nucleus break into smaller nucleus and release lot of energy, and nuclear fusion is just opposite of that one. Smaller nucleus join together form large one and release lot of energy. Now look, small nucleus join together and form large nucleus and release lot of energy, and this process is called nuclear fusion. And next point, in sun and star nuclear fusion process occurs. Sun mainly hydrogen isotopes, that is deuterium and tritium, join together form helium nucleus and release neutrons and huge amount of energy. This process is going on in the sun and star. Here look, deuterium and tritium. The mass of deuterium is 2 and mass of tritium is 3 and join together. Total mass is 5 and release one neutron and plus helium and release lot of heat energy. This process is going in the sun and star. In sun, we know nuclear fusion processes occurs in the sun and release lot of energy. This energy have different frequencies that we are getting in the visible light, X-ray, gamma ray, like electromagnetic spectrum. Maybe you study last year, grade 9, you study electromagnetic spectrum. This energy in different frequencies. That's why we are getting different spectrums, electromagnetic spectrums. Okay. Then we can check what are the difference between this fission and fusion. Difference between fission and fusion. Fission reaction does not occur naturally, but fusion reactions occurs in stars and sun. And it produces many highly radioactive sources, and fusion produce few radioactive particles only. And nuclear fission energy released is million times greater than that in a chemical reaction. In nuclear fusion, energy released is 3 or 4 times greater than fission. Okay, these are the difference of fission and fusion. We discussed nuclear fission and fusion. Actually, we don't want in a detailed way in our syllabus, 2020 and 21 syllabus, it is not that much. Only we have to understand the term nuclear fusion and fission. One more point, this connection, this relation you have to remember, nuclear fission process is used in nuclear reactor and nuclear fusion process in sun. These two things remember, and now the atoms and radioactivity topics over. Then we can go to some questions. Okay, revision questions. A lot of questions are there, you can see in the past paper. While you are checking, you can see lot of questions, and some questions I taken, and we can discuss today those questions. Okay. First question, one MCQ question. Okay, 5 MCQ questions and 3 theory questions I took. Okay, first one, read the questions. The diagram shows the simple atomic structure for 2 neutral atoms X and Y of different elements. And which row is correct? It's a question. And here X and Y atomic structure is given. Then we can check atom with more electrons, in which case more electrons X in X or in Y. So here X we know 1, 2, 3 electrons are there, and in Y 1, 2, 3 and 4 electrons. So we got the first point, atoms with more electrons, we know Y having more electrons. Okay, so C or D will be the answer. And second part, atom with more positively charged nucleus. Remember this thing, an atom contains equal number of protons and electrons. So how many electrons are there? The same amount of protons also will be there. Protons have positive charge. Okay, so here 3 electrons in X, so 3 protons also, that means 3 positive charge. And here 4 electrons, so 4 protons, that means 4 positive charge. So which one have more positive charge? We understood that one, Y having more positive charge. So we got the answer, D is the answer. Okay, then go to the next. Second question. Question number 2. Plutonium-238 decays by the emission of an alpha particle. Which equation represents the decay of plutonium-238 nucleus? Okay, always in MCQ, most of the time the second question is decay related question. And in this alpha decay, before that you have to, before doing the answer, you have to remember this point. When an alpha decay occurs, atomic number decreases by 2 and mass number, that means nucleon number, decreases by 4 for the new element. So here also we can check, in the first case atomic number not decreased, it is increased, so that is wrong. Then second case, atomic number 94 here, and here 92. So, atomic number decreases by 2 and mass number 238, here 234, mass number decreases by 4. Alpha symbol, remember, alpha atomic number is 2 and mass is 4. So, we got the answer is B, because atomic number decreases by 2, mass number decreases by 4 when an alpha emission is occur. Okay, answer is B. Then next question, and all the question paper you can see half-life questions, half-life calculation, MCQ, and theory also you can see half-life calculation questions. This is one half-life question. A radioactive isotopes has half-life 8 days. A detector close to a sample of this isotopes gives a count rate of 200 counts per minute. Without a source, the background radiation or background is 20 counts per minute. And what is the count rate due to the source after 8 days? Question, what is the count rate due to the source after 8 days? So, source only decaying occur. Remember that point. Here we have to start from, first we have to check how many counts or what is the count rate for the source alone. Here background is 20 and total count rate is 200. So, the count rate of the source is 200 minus 20, that means 180. This point you have to remember, then only we can get the answer. Okay. So, count rate due to the source in the beginning is 180, and after half-life, one half-life, it will be half of this one, 90. So, half-life is given here 8 days. So, after 8 days, how many counts from the source? 90. So, we got the answer. What is the count rate due to the source after 8 days? Answer is 90. Next question. Why are some radioactive sources stored in box made from lead? We know always radioactive sources we are keeping in a lead box to protect. Okay. Then check what are the which is the correct answer. First one, lead absorbs emission from a radioactive source. Lead decreases the half-life of radioactive sources. Lead increases the half-life of radioactive sources. Lead repels emission from the radioactive sources. Why we are keeping the radioactive source in a lead box? We know lead absorb alpha rays, beta rays, alpha particle, beta particle, and very few gamma particle only can go outside. So, which is the answer? We got the answer. A is the answer. Lead absorb emissions from the radioactive sources. Okay, clear? Then now we discuss 4 MCQ, one more MCQ question we can check. Then next one, which observations provide evidence for the nuclear atom? And answers is given: attraction of opposite charges, emission of gamma rays during the decay of radioactive nuclide, scattering of alpha particle by thin metal foils, scattering of gamma rays by a thin metal foil. We know last class I explained Rutherford alpha scattering experiment. In that experiment he concluded 3 points. Nucleus is very small and in an atom lot of empty spaces, and nucleus having positive charge and it is dense and heavy. So, structure of an atom, evidence for the nuclear atom. Answer is scattering experiment, Rutherford's alpha scattering experiment. So, we got the answer, alpha scattering experiment, alpha scattering of alpha particle by thin metal foil. Now we can go to some theory questions. Okay. Then some theory questions we can check. First question. The nucleus of hydrogen atom is a proton. The mass of proton is m, and the size of the proton, size of the charge on the proton is E. Complete the table. It's a question. We can try to complete this table. Then here, proton mass is given m and proton charge is given E. Neutron mass is given m and neutron charge we have to first find. Neutron charge. Okay, what's the charge of neutron? Neutron, we already study, neutrons have no charge. So we got the first answer, we got here 0, no charge. Neutron charge is 0. Then next one, gamma ray. Gamma ray mass and charge. Mass of alpha particle is 4 and mass of beta is very less because it is similar to electron, and mass of gamma is no or 0, no charge. So we got, no mass. So we got the answer, first one, we got the answer here, mass is 0 and charge. What is the charge of gamma ray? Alpha particle charge is positive, beta particle charge is negative, and gamma particle or gamma ray is no charge. So here also 0. Understood? Then next one, nucleus of helium. Nucleus of helium, mass of helium nucleus. We know helium having, or alpha particle is same as helium nucleus, that having 2 proton and 2 neutron. So the mass is 2 plus 2, 4 gram. Okay, 4 is the mass, here 4. And charge of helium nucleus. This is, here we will get, we have to write answer 4m. And charge of helium nucleus. Helium nucleus contain proton and neutron. So helium nucleus contain 2 proton, the charge is 2. Okay. So here proton charge is given E. So here answer is 2E. 2E is the answer of that question. Understood? Okay. Here 4m and here 2E. Okay, clear? Then next part of this question. Many schools and colleges use radioactive isotopes for teaching and research. Describe how these radioactive isotopes are handled, used and stored in a safe way. This is one of the repeating question, always asking this type of question. Used and stored in a safe way. Okay, always first point, remember, always while we are doing any experiment using radioactive materials, use a tongs to take the radioactive material. So first answer we got, use a tongs to take the radioactive material. Second one, wear a protective cloth, that means wear a lead suit. So second answer also we got. First one, use tongs to take the radioactive material. Second one, wear lead suit. Then third point, always keep the radioactive material in a lead box. Fourth point, while we are doing the experiment, very short interval of time or short period of time only we have to open the lead box. And one more, we have to stand maximum away or keep distance while we are doing the experiment. Okay. From this, any answer you can write. Any 3 points you can write. Again, some more points is there. So any 3 points you can choose. So use tongs, we are lead suit, keep distance while we are doing the experiment. Then always keep the radioactive source in a lead box, and doing experiment a short interval of time only you have to open the lead box. Okay. Then second question, another theory question. A radon 222 nucleus contains 86 protons and 136 neutrons. It decays by emitting an alpha particle, become a nucleus of an isotope of polonium. The symbol for radon is Rn and the symbol for polonium is given Po. Write down the equations. This decay equations also asking. Here they are asking, we have to write the equation for this alpha decay. They given radon 86. Okay, 86 protons. So radon symbol they give, it is Rn, 86 protons and 222 is the nucleon number, and it emit an alpha particle. So alpha particle is emitting alpha 24. So new element is formed polonium. Polonium is the new element. What is its atomic number and nucleon number? That means mass number. We know when an alpha decay occurs, atomic number decreases by 2. So 86 minus 2 is 84, and mass number decreases by 4. So 218. 222 minus 4 is 218. This is the equation for this alpha decay. Okay. While you are doing the equation, you have to be very careful. This for this 1 mark, and while if you are writing this part clearly, you will get 1 mark. Like that way, 3 marks they distributed. Okay. Understand? Then second part of this question. It's also one calculation question, half-life calculation question. Here, carbon 14 is a radioactive with half-life of 5,700 years. An animal bone is dug up in an archaeological excavation. The quantity of the carbon 14 in the bone is 25%. That means 25% only remaining now. What it was when the bone was buried. Calculate the time that has elapsed since it was buried. Okay, we have to find the time taken. At present, 25% of the carbon 14 remaining in the bone. So in this type of percentage is given means we have to fix. First we have 100%. Okay, then I am starting that one. First we have 100%. After one half-life, how much percentage will be there? After one half-life, half of this one, 50%. So one half-life over. One half-life is 5,700 years. 5,700 years. Now, at present we have 25% only. So again, half of this one, 25%. So we reached 100 to 25%. First we fixed we have 100%, and after finally reached to 25%. One more half-life. So again 5,700 years. So total time taken to reach 25% is 5,700 plus 5,700. So 11,400 years, that is the answer. Clear? So 5,700 years plus 5,700. Answer for this one. Understand this one? Okay, one more question we can discuss. The third one, a detector of ionizing radiation measures the background count rate in a classroom where there are no radioactive samples present. There is no radioactive samples present. Reading in counts per minute taken over a period of time are shown in the table. So counts per minute 16, 12, 14, 16, 15, 17. Now state two possible sources of background radiation. We know this is a background radiation because there is no radioactive source. Background radiation we got 16, 12, 14, 16, 15, 17, that counts per minute. So first question, state two possible sources of background radiation. Already the previous class discussed that one. Background radiation main sources are rocks, cosmic rays, radon gas, nuclear waste, then food, like that. Lot of examples are there, lot of sources there. Okay, from that any two you can write here, two possible sources. So rocks, cosmic rays, radon gas, nuclear waste, medicines, food, like that. Lot of, from that any two you have to select. Okay. Then second one, explain why the readings are not the same. These readings not the same. We are not using any source, only background radiation we are getting, but the readings are not same. That also, this point you have to remember, radioactive process is a random process or spontaneous process. The two words we are using, random or spontaneous. That is the answer here, random or spontaneous. And here always remember, radioactive process is random in direction and random in time. That means, for example, this is a radioactive source. If I am keeping a GM tube, here I will get the reading, here also I will get the reading, here also I will get the reading. We can't predict which direction it is emitting radiations. Same way, after 10 minutes, I can't say fixed number of radiations. That will vary. Okay. So remember, the answer is why the readings are not the same. Answer is radioactive process is a random process or it is a spontaneous process. Okay. Then again one more half-life question, because I selected half-life question because all the question paper you can see one half-life question. Here, with no radioactive sample present, the scientist records a background count of 40 counts per minute. He brings a radioactive sample close to the detector. The count rate increases to 200 counts per minute. After 24 days, the count rate is 50 counts per minute. Calculate the half-life of the radioactive sample. That is the question. Okay. So in this, some information is given. First one is background count is 40, and when we place a radioactive source in front of the GM tube, in front of the detector, the count rate now increased to 200, and after 24 days the count rate is 50. Calculate the half-life. That is the question. So we can check. Remember this point, background still remains there, only the radioactive source, the count rate is decreasing. Okay, only the radioactive source count rate is decreasing. So first radioactive source count rate we have to think. Background is 40. When we are placing a radioactive source, the count rate is 200. So what is the count rate only for this source? Count rate of this source is 200 minus 40, that means 160. So from 160 we have to start. 160 we have to start. Okay. Now we can check. We have to reach 50. 160 is the count rate. Now half of this one is 80. Again half of this one is 40. Again half of this one is 20. Now just we can check how much is the count rate in the detector. 20 is the count of this source plus 40 background remains there. So 20 plus 40 is 60. So we didn't reach 50. One more, again one more we can check, one more half-life, that is 10. Now the count rate of the source is 10. So total count rate in the detector is 10 plus background, that means 10 plus 40, that is 50 now. So now we reached the count rate 50. Okay. Now we reached total count rate is 50. 10 plus 40, 50. So total time taken for this 24 days. 24 days. How many half-life? 1 2, 3, 4. So, one half-life is 24 divided by 1, 2, 3, 4 half-life. 24 divided by 4, 6. 6 days. 6 days is the answer. Okay. And here in this type of question, lot of students will make mistake. They will not subtract this one. They will start from 200, then will get wrong answers. So you must care. In this type of question, background is given means first we have to reduce the background from the source, then start half-life calculation part, then try to find the answer. Okay, understand? Then last section, the one more question is given. This is related uses of alpha, beta and gamma. So here match the following question. X-ray already they given, then alpha particle. Alpha particle we know high ionizing effect and low penetrating. So from this which one we can select? It is a most ionizing radiation. So alpha particle, most ionizing radiation we have to match. And second, uses, alpha particle is used in smoke detectors. Okay, so we got the answer alpha particle. We have to match here most ionizing radiation and detecting smoke alarm. Then beta particle. Beta particle can penetrate. Then penetration is affected by small changes. This is a beta particle. We have to match here, and also it is used to checking the thickness of paper and thickness of a sheet like that. So beta particle we got the answer this one, and detecting the thickness. Then gamma rays. Gamma rays are highly penetrating. So we got the answer gamma rays are highly penetrating and also detecting the leaks in underground pipes. Okay, so uses of alpha particle, beta particle and gamma rays also asking in the question paper, that also you have to study. Then because last day some students asked this question, do we have to study uses of alpha, beta and gamma? So that's why I took this question. Okay, so uses also you have to study. Then thank you for listening. I hope all of you understand this topic, atomic physics. Okay, we can meet next time with a new lesson. Okay.